All right. Can I start with a quick show of hands? How many developers do I have in the audience? We got 1, 2 over there, 1 over here. Okay. Well, this is going to be interesting because this is a talk that was sort of contrived for developers in the first place. But hopefully everyone will learn something from it. A lot of it focuses on basics. When people stop making basic mistakes, I'll stop giving talks about basics. So, a little bit about me. My name's Mike. Sometimes people call me Mick as well, like the entire United Kingdom, for example. It's a true story. I worked with a UK company for a whole bunch of years. And so I should know what I do. I'm a senior security consultant at Secure Ideas, so I do mostly pen tests. That's not entirely true. I spend half my time doing pen tests and half my time writing reports. And half of that is fun, and half of that is nobody likes. I've got a lot of development experience. I started in the 80s, which is probably hard to believe, looking at me, I hope, still. I started writing like DOS batch scripts and then BASIC kind of in sometime around 88, and just kind of kept slinging code through, you know, when my age hit the double digits finally, and through my teenage years, and basically somewhere around 97, I started throwing stuff on the internet, which I didn't know what I was doing at the time. Some of that was GeoCities sites, you know. Everybody remember those? Fun stuff with frame sets. Eventually, I ended up putting in about 10 years of web app development, and 5 as a system integration consultant. So that's pretty much my resume. Not that I'm looking for a job, of course. I got a reputation, kind of among people that know me, mainly my coworkers, for being particularly nasty if I find a cross-site scripting flaw. It's not to be mean. I mean, sometimes I only have time to throw an alert pop-up anyway. But I tend to be able to insert some code into the flow that doesn't break anything. And everybody thinks that's mean. I don't think that's mean. I think I'm being nice. But when I did my web app development, I did a bunch in Java. I did a bunch in .NET. I did a little bit of Ruby. I did a little bit of Node. I've done a lot of different things. Back end kept changing. The front end was a constant. You know, it stayed the same. And a lot of the time I had full stack responsibilities because people don't like hiring user interface guys, I guess. I don't know. And so because of that, I ended up picking up more JavaScript experience than everything else. And I've put stuff in production, and I could try to rattle off a bunch of languages, but I'd probably stumble over it because I'm a nervous speaker and I ramble. But I put stuff in production in Perl. I put stuff in VBA jammed into an Excel file. I've done some horrible things that I need to confess. And I've done some pretty slick stuff too over the years. That experience has sort of taught me, when I look at a web app, which I do a lot of web apps, when I look at a web app, I have a pretty good idea a lot of the time where I would have made a mistake as a developer, or where a developer would make a mistake. And usually what that comes from is an assumption that is not entirely correct. It's, say, 75% correct. And that, I think, for me, has made me a pretty good attacker on the other side. One of my favorite parts of the job is constructing attack scenarios. And that's you get a little flaw here, a little flaw there, you start piecing them together and you see what you could maybe do with them. And being able to narrate that, I find particularly fun. It's a really interesting mental exercise. So I would say just because something looks like a minor flaw on its own, or you know, it's a medium, it's not a shell, it's not cross-site scripting, doesn't mean you need to write it off. It might click together with something else you find. prone to saying Zed. So I did my first BSides talk at Charleston last year. And I probably spent 5 minutes trying to point out a Z on the screen, and nobody knew what I was talking about because I'm actually originally from Canada, and I was pointing at a Z, and everyone thought I was strange and crazy. And so you hear Canadianisms if I start talking about something and it sounds a little funny, that's probably where it's coming from. I put my Twitter handle up there as well. Last time I was in kind of the end of the day slot, and everybody went for beer. Like the people from my own group up around Charlotte were tweeting it from the bar, and I was picking it up, and I was like, okay, that's great. You're having a beer, and I'm, super nervous and hiding behind a podium. So I told everyone that time, take out your phone, tweet. I had 5 people in the audience. I said, tweet about how awesome this talk is that everybody's missing. I don't think I'm going to say that this time, but you're certainly welcome to. Okay, so what I have today, I've got 5 sort of case studies, and they all follow the structure of what I call the smell, sort of the same idea as a code smell. It's something that I see immediately observable in the application that makes me go, yeah, there might be something wrong there. I should take a closer look. Sometimes it's legitimate functionality. Sometimes it's a false positive. But a lot of the time, it is also something else, something bad. And originally, it wasn't planned to be a talk all about stuff in the in the URL, in the address bar. But a lot of it kind of worked out that way when I picked the cases. It's not going to be comprehensive. It's going to be kind of a greatest hits. And we're going to talk a lot about various things that you'll see in the query string and what it could mean, how I think I might be able to use that as an attacker, depending on what you've done or what a developer has done, and how that should be remediated, which for I think 3 developers in the room might be useful, or for anybody who has to write a report about it after they find it. Okay. So case number 1 is a simple one. You see it all the time. Somebody has put a URL in a request parameter, right? You see often in this example, it's some part of the authentication process, and it's the person's been directed there. You kick them out to the login page because they don't have a session. You want them to log back in, right? You see that all the time. That is not in itself a flaw. However, and there are 2 things to look at there. There's the request parameter and the endpoint. However, how does it work, right? And you're going to have to play with it to figure that out. Does the server use it to retrieve a file? So if it's actually referencing a file on the system, or it's appending an extension onto it in this case, or if it's got a file with an extension, it doesn't guarantee anything. And that's going to be the case with all of these, and I'll try not to repeat that too often, but it doesn't guarantee anything. And I don't see this as often anymore. The better ones are coming up. There's a potential there for a directory traversal. You try throwing like a dot, right? Navigate up the file system. Navigate laterally, maybe, if you have an idea what something else in there might be called. Try some common file names. There's a potential for that. If it happens to be going into some sort of a command, there's a potential for command injection, maybe, as well. And that's a bit of a long shot. That's sort of the best case scenario, and most of the time that's not what you'll see, even when it is flawed. What I find a lot is that it'll take an absolute path, which means I can have a URL on your website point to something on my server. That's usually bad in almost every case. I mean, there are certainly a few exceptions, but you usually don't want to see that. So I can put an absolute path in. Let's start from there. What's it doing? If it's redirecting, so it's an open redirect, so it's good for social engineering. I can have a link that points to your domain that actually lands you in my site at the end. Where that is especially nice If you see one that has some sort of authentication process where it goes, does this person have a session, then forwards them to the correct page, or it kicks them to the login page and then forwards them to the supplied page, and it persists that parameter, and I've seen this several times, it's really handy for a cross-site request forgery attack, right? Because they have to have a session. So you get them to log in on their own website and then redirect them to your page with your CSRF payload. Everybody know how cross-site request forgery works? That's something I should cover. Show of hands if you'd like me to cover CSRF. We got a few. Okay. So the short version, the easiest way to explain it is if you have a cookie from a website, let's call it facebook.com. You have a cookie from facebook.com, and you can issue requests on facebook.com with that cookie. Submit the form, it checks that you have a valid session, it does the thing. If you go over to my site, evilsite.com, and my site submits a request to facebook.com from your browser will append that cookie. And that's where you see things like on a password change, and this is for me, it's kind of the classic CSRF example. A password change prompts you for your old password, because if you can't validate that, my CSRF site can't validate that unless I trick you into putting it in. If you can't validate that, then it's not a legitimate request, and that's also where the tokens come in. If you've seen CSRF tokens, is a piece of information that is not exposed to the attacker who's standing up a CSRF site. So, whereas if you just took the new password, not the old password, even if you had it on there twice for the confirmation, and I knew the structure of the request, and you were logged in on that site, you had a session, and I submitted that request when you browsed to my page, then I could change your password. Essentially, is what it comes down to. If I haven't explained that well, or if you want me to go over that more or again, find me after. I got one of the tables out in the lobby. The other part's the endpoint, and that's where I was talking about. How it's used is important. And another example I saw that took an absolute path didn't go there at all. It wasn't a redirect. I couldn't tell what was happening until I pointed it at a site that I controlled, and then I could see that I was getting an HTTP request, but not from me, not from my browser. That request was coming from the server. It was an API call. So they put the URL, they put right in the query string the URL that they were going to submit their API call to. So what did I do? I pointed it at my server and made the API call to me, and then returned data. And this is one of those, when I was talking about assumptions that are mostly true, but there are exceptions to. It's an opportunity, you find something like that. I'm sending my response instead of a response from a server they think they control. I'm introducing my payload into a context that is supposed to be trustworthy. And that's where you'll see them escaping. That sort of thing that can get you an injection. And so those are my two favorite cases of things I can do with an open redirect. It's always nice to just be able to go, okay, this is targetsite.com, not Target the store, obviously, because I would not be involved in something like that. Walmart. It's a bad joke. Why didn't Walmart get hacked? Right? Because they're not a target. This is. Yesterday, I was teaching a class with my boss. That was his joke. I stole it from him because he's not here. So, mitigating it. What do you do? Pardon me. It's always going to be something like this. It's going to be, well, it's probably better not to do that if you can avoid it. If you can design your application so it's not necessary, that is your best fix. However, If you're expecting a relative path, you're expecting something else, you're expecting it to only direct to things on the same site, then enforce that relative path. Make sure nobody's tacking a protocol and a domain onto the front of it. I would do that with regular expressions. I'm sure there are other things that people might use to do that, and a lot of libraries probably have built-in tools to validate that sort of thing. Directory traversal. If you have the ability to expand, and I think everything does, PHP even has this ability, to expand a relative path into an absolute path and compare it, that's a common way to check for directory traversal. If the directory that it resolves to in the absolute path is not downstream from the relative path that you were expecting it to land in, then somebody's trying to traverse. If you have to do something like that API case where you're pointing to other servers that you control, use a whitelist, right? You have a finite number of servers. You know that it can only go to those ones. Make sure it's going to those ones. And with anything like that, and people are really good about validating that text boxes don't contain malicious stuff. People forget all the time various other parameters, hidden fields, stuff in the URL. And so treat it as user-supplied input. Escape it if you're going to echo it. That sort of thing. Always use HTTPS. Why is that there? Because people don't use HTTPS, for one thing. And right now, I don't think there's a valid reason that I've heard not to for the entire internet. But there's also a corner case I wanted to deal with, and that's why I put that up there. Say you have a legitimate redirect to another absolute path, to another domain, and it's supposed to go to that domain under HTTPS, and I take the S off of it. I'm able to remove the encryption from the transport layer. Hopefully you have other protections to prevent that anyway. But downgrading it, removing the encryption, opens up opportunities and takes things like passing credentials. It makes them a lot more vulnerable to stuff like man-in-the-middle attacks, right? So that's, I think, about all I wanted to say about that. Before I go on to the next case, did anybody have any particular follow-up questions to that one? No? Cool. Okay. JSON object. There's an asterisk on there in the URL. I told you we were going to spend a bunch of time up there. And this one, okay, here's a hint. It's not a JSON object. They're taking a string representation of a JavaScript object, which is not explicitly the same as a JSON object. And this one's going to get a little code heavy, just forewarning. It's the only one I think that I did that has a bunch of code in it. So it's a JavaScript object, and they're going to take that, they're going to unsafely interpret that as a JavaScript object. And I saw this, the first time I found this was in a security product, flagship product from a security company in their web interface. Immediately, I see this sort of thing in the address bar. Of course I'm going to play with it, right? I'm going to see what I can put in there. Executable code is what I really want to put in there. That's just for convenience sake. I've taken away the URL encoding on it. Okay. So, and I did a whole bunch of this stuff with the JavaScript console. Hopefully you can read it all right. It's kind of the smallest font in the whole deck. So, yeah. So I've done an example. It's functionally equivalent to what I saw and to what I've seen elsewhere. I haven't picked apart every one and seen how they've unsafely handled it. But this is a really simple example of it. Do I have a cursor up there? Yeah. Eval. Don't use it, ever. If you're at a point where you're using an eval in your JavaScript for anything that could have user input appended to it, you're already insecure. But in this case, okay, taking it through quickly line by line, I took that payload that was in the URI on the title slide, and decoded it into a string. Now I've passed it into this eval that's going to assign it to a variable. And if with that payload, it's producing the object just as somebody would expect. But it's obviously, I think most people in the room have probably realized it's obviously an unsafe thing to do. And here are a few ways that I've tried that work for exploiting this sort of thing. So if you look here, I've jammed an object in there with the toString override in JavaScript, which is basically I assigned a function to that object called toString. In this case, I had it log the letters XSS out to the console. It's cross-site scripting. And return the value of string because this object got swapped into the field that returned the type, which was string before. So I passed it into the same eval function. What I got out of it is slightly different. It has an object where there was a string before. And that's where you see, and this is important, when I look at somebody's JavaScript script code and I see a lot of equality operators that are double equal signs, I immediately get suspicious that they're Java developers. It's maybe a bit of snobbery on my part, but I get suspicious that their JavaScript developers don't know what they're doing. Because, does anybody know the difference between 2 equal signs and 3 equal signs in JavaScript? That's right. 2 equal signs will do type coalescence, so it will try to convert it. 3 equal signs, it will not, and if they're not the same type, they don't match. And which is why you can see when I compared it with 3 equal signs, it never called toString. It never called that toString I injected in there, so it came back false, and that's all that happened. When I compared it with 2 equal signs to a string, it actually came back true for one thing, which it's not. And it ran my console log command. It executed my cross-site scripting because that toString function got called in order to do that comparison. So this is an okay example. It's not ideal. I've changed the structure of the object. It's a little bit broken now. But it is one tool that is available for that sort of thing. I have one more, and I think it's better. I like to show both, but I think my second one is better. JavaScript closures. If you want to build really good cross-site scripting payloads, being comfortable with closures helps. In this case, what I've done, so I have this function. Let's start by just looking at the function. It logs my command. It returns the string with the word string in it. That's fine. It's also surrounded in a set of brackets and followed by a set of brackets. And what that will do is cause it to get executed right away. So in the eval statement now, you can see when it's called, my code gets executed immediately in the eval. As soon as it becomes an object, that's getting executed. And if you look down here, the type is actually string as it was before, as it was in the benign example, the non-exploited one. So they're getting the same object back downstream in the app, but my script is just run. Obviously bad things, right? Cross-site scripting generally gets rated way up near the top of the danger scale, whichever risk index you're using. And there's a really good reason for it, because if I have cross-site scripting, I can control your entire experience with your app, basically. I had a really good one a little while ago. It was just a couple of weeks ago. And it was cool because within the app, although there's some protections, I I could build the payload in something that I controlled within the app. It was a task list, I think, and invite somebody else to look at it. I could invite anybody by email address, but there was also a contact list built into the app. What's cool about that is as soon as I get execution in that person's session, as soon as they accept my invitation and go look at my list, I can pillage their contact list and send the same sort of invitation out to everybody they know. Just one cross-site scripting payload injected there could snowball through everybody who knows everybody in the app, 6 degrees of separation situation. And as soon as I'm working off their contact list, there's a level of trust as well, which makes it even that much more likely to succeed. Mitigation, right. The best way to do it, there's a function built right in there, json.parse. If you do it with a legitimate object that doesn't contain functions, doesn't contain closures, doesn't contain executable code, which is not supported by JSON, and that's an important distinction, it'll work fine. And that's what I've done here. It's the same normal expected payload as before. It gets parsed into the same object as before. It's fine. I stick my cross-site scripting payload in there. Any valid cross-site scripting payload that I know fails. It won't parse because you can't have executable code in there. Everything in JSON has to be both the, say, key and value, we'll use that as the term, both the key and value have to be enclosed in quotes, or you could have arrays with braces, but within them, unless you're dealing with numerics. So you can't shove a function in there because you're going to end up having a string representation of your function that is just the function. Unless it's mishandled by like an eval statement downstream, you don't have execution that way. That's good. Before we move on, and this is obviously, I've already popped up the title slide. This is obviously something that people have to do all the time, right? Dropbox wouldn't exist without this sort of thing. Before I go on to this, did anybody have cross-site scripting questions that I can answer quickly? If not, you can also, like I said before, come and find me. No? Okay. So, user-supplied files for download. The problem with files is the same as the problem with query string parameters, and that's that they're not necessarily always treated as input fields, and they are input fields. Yeah. So this is a directory on my my laptop. These are files. If you give me an upload, I'm going to upload all of these and try a few other things. There are a lot of parts of a cross-site scripting payload that can be escaped, and in a way that you can actually have an intact payload to upload in the form of a file. Alert pop-ups, right, where I'm showing a bunch of alert pop-ups, and I said alert pop-ups, they don't really show much, they suck. That's true. I have a script, and I really need to do a character count on it. It's approximately the size of a tweet. It's about 140 characters. It does an XML HTTP request out to a server of my choosing, fetches a file, a JavaScript file, and evals it. Right. If I can get enough in to do that, then I can run whatever I want. So, yeah, looking here, this one, you're listing files in a context that looks like HTML. I can shove something like that in there. By the way, common way to access divs and stuff and throw stuff in there is to use inner HTML, right? If there's user input in there that's not escaped, it can contain HTML and it'll get rendered. It's always something that's worth a look. This one, and this is a somewhat more modern. It's, I believe, an ES6 convention, if I remember right. I've used backticks. Why? Somebody's probably blocking brackets, right? That'll run. It's part of the literal template system in newer JavaScript, but I throw that in, it'll actually execute an alert one with that. Try to get into multiple parameters, it gets to be a problem, but for one, you can do that, and that's just a filter evasion technique. Usually, although these say J. Gillam, which, so I stick my brother's picture in there. I actually often stick my, Kevin, the CEO of the company, whose joke I stole, I often stick his head in there, and he hates it, kind of, but I think he secretly likes it. So, and then I screenshot it in the report, of course, so the client gets a report with like 3 pictures of Kevin's head in there in various cross-site scripting attacks. He just found that out the other day. It's been going on for a while. He went to review a report and said, why am I looking at myself? And then directory traversal, of course, which if somebody has found a way to stick 2 dots into a file name in well, in this case it was OS X, but in a Unix file system, I sure would like to find out what that is, because I have tried and I haven't gotten it. But you can do that by using your man-in-the-middle proxy and shoving it in that way, just playing with it. So directory traversal, and that's not so much on the upload part, that's more on the download. You're just going to, if there's a download, you may as well try a directory traversal, especially if it's user-supplied files. Because it's not necessarily just, can I navigate out of the web directory and grab the Etsy password? It's also, can I navigate up a level, over a level, and back down one and steal another user's stuff, right? Potential auth bypass. Protect the file name from injection payloads. Yes, please. It's a user input. It's supplied by a user. Don't trust it any more than you trust anything else that comes from a user. Users always lie. Ideally, assign an identifier, use it to access it. Storing stuff, accessing, particularly it's referencing things by their file name down the line, is where a lot of this stuff works. And although there are safe ways to do that, people do dumb things all the time. If you tokenize it, basically, if you generate some identifier for it and use that when you need to retrieve it, you're a lot less likely to fall prey to those dumb things. And it's always good to just have habits of doing things in a way that is safer. That's kind of one of my rules on life, right? It's, well, I got my passport. I'm about to go to the plane tomorrow. I'm packing the night before. Am I going to put it on the counter where I need to grab it? No, I'm going to stick it in the bag that I'm definitely taking, no matter what. The only way I'm not taking the passport to the airport is if I forget my whole bag. It's the same sort of thing. It's excuse me. Do something in a way that will prevent you from being able to make a mistake when you can. And consider renaming it on disk as well. You can return it with any file name you want, but random things like that, or maybe it's just me complaining that it's ugly on the file system and I've put them on my own laptop. I think I would prefer file names, especially if they're handled by other processes as well, because there's potential to exploit another application using a piece of middleware. It's just generally nicer to normalize them somehow. I think that's about all I had about that. And I think we're going to be struggling to get to get a 5th case in here. But did anybody have any questions about files? Anybody want my directory of ugly files? Maybe? All right. Hash-driven single-page apps. What did I... Oh, I meant to take that jQuery one off. That's a spoiler. Okay. Yeah, so you see a lot of single-page apps now, and that's it. You load into the app, it loads up the interface, it fetches everything through asynchronous requests, and you never reload the page. And to get the sensation of navigating between pages, but snappier, a lot of the time they use the hash. Several different routing solutions use that. There are good ways and bad ways to do it. Is Angular a good way or a bad way? Any thoughts? I don't like Angular very much. I've put about a half dozen Angular apps in production anyway. It's a good way. It's, in general, if you use the routing library for Angular, it is believed to be generally secure in terms of its handling of it. That jQuery one, and that particular version is not a coincidence. It's an old version. I see that old version probably every other test, or a version older than it. And to be clear, I also see React applications built on top of a Rails 5 backend, so it's not like everything I'm looking at is ancient. But people don't update their JavaScript ever. They don't. They stick the JavaScript library on their server, and they don't want to touch it because they're afraid it's going to break. And I understand that because I've been on the development side a lot, and I understand that fear. That's not a good enough reason not to try. And nobody does it. Everybody gets... I can't remember the last time I tested a web app and didn't put outdated JavaScript of some kind in the report. That particular version has a known cross-site scripting flaw, and any version prior to that. And it was the handling of the location.hash inside the jQuery selector. So $ brackets, location.hash, often with a concatenation with something else in there. That was used for a lot of fun user interface things like scrolling to a certain part by clicking a button or showing and hiding tabs. And the thing with jQuery was that, I'm talking about it in the past tense, it's not really fair. The thing about jQuery was that jQuery plugins became a really big thing a long time ago. When I started web development, jQuery wasn't really around. But it's one of those things that kind of makes you feel old. Anybody watching or have watched any of the Iron Fist on Netflix? Nobody? It's not very popular? A little bit over there. So, guy survives an air crash 15 years ago, comes back to New York. He's got the music player that he had from 15 years ago. What is it? An iPod. Just made me feel really old because it's like I've got a stack of blank cassettes where I still make mixtapes, and this dude crashes for 15 years, shows up again, he's got an iPod. That's a bit of a tangent, that's a distraction. But I actually put it in my speaker notes because I wanted to tell that story. So below that was an example of one of those jQuery plugins. Probably the same guy who has this outdated jQuery might be using the outdated version of that plugin. By the way, that plugin did change their code to mitigate that problem anyway, although they shouldn't have had to. It wasn't their fault. It was a jQuery problem, not a scrollpane.js problem. And it's not the only plugin that has been called out for that problem. They took steps to mitigate it anyway once it was reported. But again, we find old things because nobody updates. I put Backbone up there. I was wondering if anybody would recognize it, Backbone. It just kind of faded away, didn't it? Backbone also was frequently used with the hash routing. I think there is at least one React routing solution that does, but not all of them do. So, update your JavaScript. It is a big lesson there. People don't do it enough. I would like to see everybody go out and try to update their JavaScript. It's going to break stuff. You know it is. jQuery in particular has done a pretty good job creating a migration roadmap for people to move up. Unless you still have to support IE8, which happens all the time and that makes me sad. But unless you still have to support IE8, you can move off of the 1.x branch. If you're on the 1.x branch, you may as well move up to the top of it because it'll mitigate stuff like that, which is a well-documented and known attack that is still out in the wild. Location.hash, the hash, everything that comes after that hash sign, user supplied, just like the file names, just like the other query string parameters, treat it as such. Escape it if it's being echoed anywhere. And that's the thing with it could be echoed. That's another thing you could do. Somebody could have a thing where their router goes, and this is a way that you potentially could bend over backwards to make yourself insecure with Angular. Put an unescaped version of that string in the top of the page, regardless of what it is, without validating that you have a legitimate route for it. I think you would have to try really hard to do that, but you could. And things that I think that you would have to try really hard to do to make yourself insecure, somebody somewhere thinks is a good idea. Inevitably, it happens. Heavily used frameworks are more likely to have flaws detected. That's in bold for a reason. It's safer to use something that's out there. It's got more eyes on it. It just is. Something that is popular. Doing it because it's popular is not good, but having a lot of users looking at, especially all this JavaScript stuff is open source. Having a lot of users looking at it means it's more likely that flaws will be found and fixed. So if you're updating and you're using something that is reasonably popular, you are less likely, although certainly not guaranteed, to be without those sort of flaws. Anybody going to drag me off stage? I'm going to stay behind my podium then. All right. Parameters and static resource requests. This is what I thought I might run out of cases. I shimmed this in there this morning, to be honest, because I suddenly just had these nightmares of it. I'm going to have 15 minutes left, and this is still here. If anybody wants to go and get some food right now, you won't hurt my feelings, but I am going to keep talking for a couple more minutes, unless they tell me that I can't, which they haven't. So, why does it matter, right? CSS files and JavaScript files, that's what I'm talking about. I start seeing request parameters on requests to those. Maybe it's nothing, and a lot of time it's nothing. And this is a trickier one because you see it all the time now. There are almost always, on at least the analytics JavaScript you see, there are almost always extra parameters in there. There are often extra parameters now. But sometimes they're a little fishy. Sometimes you tweak them a little bit, you get a different response back, and you start wondering, okay, why am I getting a different response? Am I supplying something that's tied to a user where I'm going to get back something else that's potentially an auth bypass? Particularly, and I said JavaScript and CSS, it's more JavaScript. Is it generating something that points to a specific resource it's dynamically generated but hard-coded into the JavaScript file, pointing to some resource that's specific to that user that doesn't have authorization on it? Reflection is the best one, though, right? Is whatever I'm sticking in the query string showing up in the file? Because if it is, I can probably get something to execute. And it's the same story again, and this is a short one. Don't generate JavaScript dynamically at runtime and without a really good reason, and I haven't heard one yet. If you don't need to do it, don't do it. You're much better off with, you can do it as part of your build process, right? Bundler or other bundling tools, Browserify. There are a lot of good tools for putting together something like that, but that's a build step. It's not a runtime thing, and it's not taking user input, which is the real problem. And again, business as usual with regard to request parameters. They're request parameters. Treat them as user input. Always treat them as user input. If it's in the request, it's user input, basically. Hey, questions? We made it to the end, sort of. Anybody have any questions? Everybody just want to get out of here? All right. Have a good BSides, everybody. Thanks for coming out.